So we're going to keep pushing through. We'll see if we get through all of it. I don't know if we'll finish it today or not. But this section usually takes several days, so. All right, so not 16. We did 16. 18. Yes?
Hey, are you able to pick up?
Yep. Hey. Okay, I'll let him know, and we'll probably be done a few minutes early, and I'll have him come get it. Yep, bye. You left your phone charger. It's in Pastor Thor's office now. All right, so we've got x squared plus y squared equals 25, and we're doing it at the point 3, negative 4. So we're taking the derivative of this, getting y prime by itself, and then plugging in the values for x and y, and that's going to give us our slope, and then we're finding the tangent and the normal. So the only real difference is now we're plugging in an x and a y value instead of just an x value to find our slope. So take the derivative. I have 2x plus 2y and then y prime equals 0. Then I just need to subtract 2x, divide by 2y. So y prime is equal to negative 2x over 2y. Obviously, 2's cancel. So I have negative x over y. And then I can plug in the values. So I have negative, I'm just going to do this, 3 over negative 4. So that just becomes positive 3/4. So this is the slope of the tangent. So anytime we take the derivative and we evaluate it at a point, that's always giving us the slope of the tangent. So even if they were just asking you for the normal, we would have to find the perpendicular slope before we could do that. So now I just need to write the equation of the line. So the tangent y plus 4 is equal to 3/4 times x minus 3. And then up to you if you leave it there or take it the rest of the way, but we would end up with y is equal to 3/4 x minus 9/4 minus, I'm going to go ahead and make this 16 over 4. So y is equal to 3/4 x minus 25 over 4. And we just leave it there. All right, then the normal, what would the normal slope be? Yep, negative 4 over 3. So y plus 4 equals negative 4 over 3 times x minus 3. This one cancels nicely. So then y equals negative 4/3 x plus 4 minus 4, obviously from the other side. So y equals negative 4/3 x. At least one of them canceled nicely. Just jump to a harder one. This one's much harder. Okay. We're gonna go big or go home on this question. 26. X squared cosine squared of y minus sine of y equals 0, and the point is 0 pi. So there's a lot happening in this problem because pretty much everywhere that I have like the trig function, I've got a chain rule going on because the y's inside of that. Probably the first thing I would do is rewrite this as the cosine of y all squared, just so that I don't forget the square, but you don't obviously have to rewrite it. All right, so derivative. I got a quotient rule, or not a quotient rule, my goodness, product rule. So the derivative of this first thing is 2x. and then times this piece to the cosine of y squared. And then plus the first thing, so x squared, times the derivative of this whole thing. So I've got a pretty big chain rule happening here. So this is going to be 2, I'm going to put that in front, cosine of y times derivative of the inside y prime. So I guess that wasn't as bad as I thought it was going to be. So that takes care of, oh wait, I did not do that right. Hold please. I took the derivative of the outside. Now I've got to take the derivative of cosine itself. So now I have times the minus sine of y, then the y prime. There we go.
How come it's 2x squared?
I moved the 2 that came off the cosine in front. I just put it in front so I didn't have to have another set of parentheses. Although with all of this, I probably should have just put it in on parentheses. And then I've got minus the sine of y, so the derivative of that would be minus the cosine of y, y prime, equals 0. So I know that I'm moving this whole first piece over, subtracting it, and then I'm going to do this just so I can see this. I'm going to bracket this stuff off so that I don't lose what's happening here. So then I'm going to take a y prime out of both of these pieces in the same step that I'm moving this 2x cosine of y squared over. So I've got y prime times 2x squared cosine of y, or I'm going to put that negative in front. So I'm going to have negative 2x squared cosine of y, sine of y, minus the cosine of y, equals negative 2x. I'm going to go ahead and put the squared back in here, cosine squared of y, just because now that I've done the derivative, I don't really need it to be outside. And then basically now I'm just dividing by this whole thing. So I'm going to have y prime is equal to negative 2 cosine squared of y over, now I have a cosine of y in both of these pieces, so I'm going to factor one out when I divide by it. So I'm going to have cosine of y times negative 2x squared sine of y minus 1. So I still have the same thing, it's just written a different way. So then y prime is equal to, I can cancel one of these cosines, so negative 2 cosine of y over negative 2x squared sine of y minus 1. And now at this point, there's nothing else. Well, I say there's nothing else. All of these things are negative, so I can make this a positive. Because negative, negative, negative. So I'm going to turn these all into positives just to make it easier. So now at this point, I would just start plugging stuff in because there's really no point in moving it any farther. And really, honestly, like once you get to here, or even if you like left this just as this was under here, you could obviously just plug in because it doesn't really matter if I simplify it all the way down. The main reason I simplified it is just so that you would see it in case this wasn't like a question where you were doing that. Anyway, so I'm going to plug in. So it's 0 and pi, so I've got 2 times the cosine of pi over 2 times 0 squared sine of pi, which ultimately that's going away, plus 1. So this whole piece goes away. The cosine of pi is negative 1. Oh, I lost an x somewhere in the process. I was like, I lost my x from up here, so I need to throw this back in over here. There. So that means that up top I have 2 times 0 times the cosine of pi. And so then that just ends up being 0 over 1, so y prime is 0. So all that to get a slope of 0.
Did you go back to where you took the derivative of everything?
Right here.
Yeah. Because I'm lost.
Yep. So here I just rewrote it in the first step. So I had a product rule and a chain rule. So I took the derivative of the first piece, so that was 2x. And then I had just copy this one down to the cosine of y squared, which I ended up over here when I moved it. I put the squared back inside because once the derivative's taken, I just think it looks nicer when it's inside. So that's that piece. And then you do plus the first piece, which was x squared, times the derivative of this piece, which would have been, I have a double chain rule here. So I took the 2 and put it in front of the x squared instead, so just multiplying, times everything that was inside, and then times the derivative of the inside of the parentheses would be minus the sine of y.
Okay.
And then from there, then I have to take the derivative of the inside of that, which is the derivative of y is just y prime. So that's that part. And so that's finished off my product rule there. Then this part is minus the derivative of sine is cosine, so cosine of y, times the derivative of the inside for my chain rule is y prime.
Alright, yeah, that makes sense.
And then I just, I subtracted, just so I didn't have to write it over and over again. I subtracted this piece, and then I took out a y prime from both of these pieces to get to where I am now. And then just basically manipulated it down till I got to that. So I have now the tangent is y minus pi is equal to 0 times x minus 0. Obviously that just ends up being 0. So the tangent is y is equal to pi. So if I have a slope of 0 for my tangent, what has to be true about my slope for my normal? And it might be easier to think about if I see that this was 0 over 1.
It'd just be -1. Wait, it would be undefined.
Yeah, it would be undefined.
Yeah.
So I don't even really need to set up my equation because my normal would be at x equals and then whatever the x coordinate of my point is. Because my y equation, since I saw that the slope was 0, I could have gone straight to, okay, well, it has to be y equals pi. And so then for the normal, it has to be x equals 0. Because to be perpendicular to a horizontal line, I have to have a vertical line.
Yeah.
So all of that chaos to get to the most simple equation of a line ever. So other than the chaos of the derivatives, are you okay with the process of the tangents and normals and all of that?
After I understood the derivative, that's good.
Yeah. I mean, that one that I just did for you is the hardest one in the section, like, of those. So I feel like, it's probably, like, there's a few that would be hard, like 24, it's a product rule with a chain rule in it, but it's only one chain rule, so it's not bad. So, but like there's one on each side, so you have 2 chain rules happening, but not at the same time. So, overall, not too bad. All right. Well, the next thing is finding the second derivative implicitly. So usually on these ones, they're pretty nice to you on the first derivative and they're not awful. The second derivative, I can't say the same for. This next problem printed is a whole page.
Jeez.
So, now obviously I was writing out like every single step. It's actually like a page and a half. But it's, you know, it is what it is. All right, so 28. We've got x to the 2/3 plus y to the 2/3 is equal to 1. So, first derivative, pretty simple, other than just simplifying it down. It's going to be relatively easy. So, I've got 2/3 x. Now, subtracting this, this is where it gets to be a pain. So, subtracting 3/3 gives me a negative 1/3 for my exponent. And then same thing with the y, except for it's obviously going to be times a y prime. So, plus 2/3 y to the negative 1/3 times y prime equals 0. And a lot of people forget on the, like, when you have just like a number by itself that it's equal to, because of we're doing implicit differentiation, you're also taking the derivative of that number. So just always make sure you watch that. So now I need to obviously move stuff over and get y prime by itself. So I'm going to subtract this. So I would have 2/3 y to the negative 1/3 y prime equals negative 2/3 x to the negative 1/3. Then I've got, going to divide by that. So y prime is equal to negative 2/3 x to the 1/3 over 2/3 y to, or sorry, negative 1/3 to the negative 1/3. So the 2/3 top and bottom actually will cancel each other. Whether you just look at it if there's a 2/3 on the top and 2/3 on the bottom, or you keep change, flip it, and it cancels. So that goes away. Now I have negative exponents, so I need to swap these positionally. So I need to move the y to the top, x to the bottom. So my y prime is going to become negative y to the 1/3 over x to the 1/3. It doesn't matter. It can go top, bottom, in front of, whatever, yeah. I usually just leave it on top just because I think it looks nicer. I don't know. It really bugs me when it's on the bottom, even though it shouldn't. Like, I don't know. So I'm just going to circle this to hold on to this because I'm going to need this value again in a little bit. So at this point now, I have to take the derivative again, implicitly. So I'm technically taking the derivative of y prime is equal to all of this. So I'm going to switch colors here so that I have something else. Let's do orange. All right, so the derivative of y prime is y double prime. It's not like anything else weird. It just becomes y double prime. Now over here, I have a quotient rule. So this is going to be the derivative of the top, so negative, I'm going to put the negative on the top for right now for the sake of doing this. So negative 1/3 y to the negative 2/3 y prime. That's all times the bottom, x to the 1/3. Minus the top, negative y to the 1/3. Times the derivative of the bottom, 1/3 x to the negative 2/3, and then all over the bottom squared, so that's just going to become x to the 2/3. All right, at this point, I have a couple of options. I can try to simplify this as much as possible at the moment, or I can go ahead and replace y prime with this negative y to the 1/3 over x to the 1/3. I would say in most cases, the best thing to do is go ahead and plug it in, because a lot of times it cancels something, and like in this particular problem, I can see that it's going to cancel because I have this on the bottom multiplied by this, so it's going to cancel. So I would take this now and plug it in here. So that means I'm going to have y double prime is equal to negative 1/3 y to the negative 2/3 times, now I'm going to take this negative from here and the negative that's in front and cancel those out with each other, so I'm just going to get rid of the negative altogether. So I've got y to the 1/3 over x to the 1/3 times x to the 1/3, and then minus everything that was on top before. But now I have a minus and I have a negative here, so I'm going to make that a positive as well. So this is actually going to be plus y to the 1/3. I'll do that in the next step. 1/3 x to the negative 2/3. I could have gone ahead and put the 1/3 in front of the y, but I'll just wait and do that in a minute. All over x to the 2/3. So now I would start canceling as much as you can, if possible. So x to the 1/3 cancel each other. I would combine the exponents here, so when we multiply, we add the exponents. So it's just going to make it a little bit nicer in this step. Debating if I want to take out the 1/3 from everything right now or just leave it where it is. I'm just going to leave it where it is for right now. So I've got 1/3 y to the negative 1/3 plus 1/3 y to the 1/3 x to the negative 2/3 all over x to the 2/3. Let's see. How do I want to do this? All right, I am going to take out a 1/3, because if I do that, 1/3 obviously is a fraction. So if I take it out and it's being multiplied by everything, I can actually move the 3 then to the bottom, because it's like a fraction. If it's being multiplied by all of that, then I can put the 1 on top and the 3 on the bottom. So do this in 2 steps so we can see it. So I've got 1/3 times y to the negative 1/3 plus y to the 1/3 x to the negative 2/3 all over x to the 2/3. So now I can just move this 3 down to the bottom. So on top I have y to the negative 1/3 plus y to the 1/3 x to the negative 2/3 all over 3x to the 2/3. Now, at this point, I have a problem because I have negative exponents on the top, but there's not a way, the way that it sits at the moment, for me to move them to the bottom. But I can if I split this into 2 separate fractions. So because this is a single thing on the bottom, it's not like being added or whatever. Well, even if it was, I could still split it. But I have 2 separate things happening. So I'm going to take this and make this y to the negative 1/3 over 3x to the 2/3 plus y to the 1/3 x to the negative 2/3 over 3x to the 2/3. And then now I'm going to move my exponents around so that on the first one it becomes 1 over 3x to the 2/3 y to the 1/3 plus over here y to the 1/3 stays on top over 3. I'm going to go ahead and add these together since they're the same. X to the 4/3. Now, these no longer have a common denominator. So, to combine them, I need to get one. So, any idea what I would need to multiply by to get my common denominator? And, like, each one's going to be multiplied by something different, obviously.
X to the 2/3, the one on the left,
Yep.
and then just y to the 1/3.
Why is my thingy glitching? What's happening? Yep. So then when I do that, I'm going to end up with, I can combine this all as one thing now. So I'm going to end up with, on top, x to the 2/3 plus y to the 2/3 all over 3x to the 4/3 y to the 1/3. And that's your final answer. So that one's kind of miserable. Let me get out of here, 34. All right, I'll do one more of those ones, but it's a shorter one, I promise. 30 y squared plus 2y equals 2x plus 1. All right, so what would the first derivative of this one be?
2y times y prime plus 2y prime equals 2.
Yep. So I can take out a y prime now. Left with 2y plus 2 equals 2. I can divide by that. I'm going to take a 2 out when I divide by it because it'll make it easier. So y prime is equal to 2 over 2 times y plus 1. That way my 2's cancel. So I end up with 1 over y plus 1. There we go. For my y prime. Now, when you take the second derivative, you can either leave this as it is. Again, I'm going to circle this so I don't lose it. Or I could technically rewrite this as y plus 1 to the negative 1 and then treat this as a chain rule instead of having to do a quotient rule. You're going to end up with the same final result. Do you have a preference?
I'll do the chain.
Okay. So we get y double prime is equal to what? Let's see how you do with the chain rule.
It'd be negative 1, or just negative y plus 1 times
Raised to the...
raised to the negative 2.
Yep.
Times y prime.
Yep. So I end up with, then, if I move this y plus 1 to the negative 2 to the bottom, I'm going to end up with negative y prime over y plus 1 squared. So that's the second derivative, but I need to plug in for the, whatchamacallit, the y prime. Now, in this case, it actually might be smarter for me to use y plus 1 to the negative 1 when I plug it in, because then I'm just taking that whole piece and moving it to the bottom, which is really the same thing that's happening here, because you have a fraction divided by something. It's just the fraction times 1 over whatever the denominator is. So the same thing is happening. It really doesn't matter. I just think it kind of looks nicer. So this would be negative, parentheses, y plus 1 to the negative 1 over y plus 1 squared. So add that over, and we end up with negative 1 over y plus 1 cubed, and that's our second derivative there. So much easier on that one, obviously, than the first one.
Why did they do that? Like, why is 28 so hard? It's like easy.
Yeah. Well, and 28 was awful because it had fraction exponents. Like, when the exponents are fractions, I'm like, why are you making me do the second derivative of this? Like, come on now. The other ones, like, they're not as bad because they have whole number exponents, so it's not like all this moving and shifting and whatever else. So it's nicer. Because with fraction exponents, you can pretty much guarantee they're going to end up negative by the time you're done. So it's like then you're moving it up and down and back and forth. And I mean, we moved stuff up and down like 8 times here. I don't even. The last two problems just want us to take the derivative. It says use implicit differentiation. Or no, it actually just says find dy dx. Sorry. So these ones are just like slightly more challenging, like first derivatives, but they're not. Like, it's stuff we've done. It's just using chain rule. So just, I'll do 2 of these. 32, y equals negative, or not negative, x to the negative 3/5. What is happening? Well, I said I'm going to do it. I may not. Come on. I think I need to restart my iPad before next class. All right, so what would the derivative of this be? Yep. And then we would just want to move that, so we would have negative 3 over 5x to the 8 over 5. Much nicer than the other ones. Last one here. 40.
Oh, that was it?
Huh?
I thought we had to take the second derivative of that.
Oh, no. These ones just want you to find dy dx. No, if I was taking the second derivative, I would not, unless they tell you find the first or say the first derivative and then find the second derivative, I would leave it like this. If I was finding it, I wouldn't move it this way.
Okay.
Because then this makes it easier to find the second derivative if I leave it in this form. And even then, I would still, even if they asked me for the first derivative, I would then go here to find the second one. But yeah, they're just asking you for the first one on these ones. So we've got y equals 3 times 2x to the negative 1/2 plus 1 raised to the negative 1/3. I really thought we were going to lunch after this. Hello? Yes. Okay. Yep. Mr. Law said to come see him when you're done with class.
All right. That's great. I don't know what I did. I don't think I did anything.
I have no idea. He didn't tell me. Sometimes it's literally just like, hey, you're doing a good job.
Okay, I hope that's what it is. Jeez.
Who knows? Or he may have your charger now. Like if Pastor Thor's leaving, he may now have your charger and yeah.
Hopefully.
Believe me, I get the calls of, can you come to my office? And I'm like,
yeah.
Like even as a teacher, so. All right, so we've got a chain rule here. So the derivative of the outside, the negative 1/3 times the 3, that's just going to become negative 1. So I've got y prime is equal to negative, and then all of this stuff inside, 2x to the negative 1/2 plus 1 raised to the negative, 4/3. And then the derivative of the inside is going to be negative. 2's cancel. So negative x to the negative 3/2.
Yeah.
And then basically, are they actually leaving these as, oh, they're leaving them as negative exponents. X to the negative 2/3. Other than making this positive for the negative times the negative, we've got that. So I'm just going to make this x to the negative 3/2 and then times 2x to the negative 1/2 plus 1 to the negative 4/3. And that's it. All right, problems. What was the last problem I gave you yesterday? Was it 6 or 13? I think.
Yes.
Okay. So the problems in 17, 19, 27, 31, 35, and 41. Obviously we don't have this class tomorrow because we're only doing 4th through 7th. So if you need some time to work on this on Monday or like ask questions, like you can. And then we'll see if you feel like you're going to be ready for the quiz on Tuesday, we can do it Tuesday. But if you feel like you need some more time, we can move it to Wednesday. We're still way ahead of where we need to be. So we're still like at least 2 weeks ahead of where we need to be, even with all these crazy days of missing class and other things happening. So